let's just focus on the design patterns, and I want to talk a little bit about I have updated this document a bit since the last time we had the last webinar. Anyway, we'll keep doing these depending on the questions, depending on what's the demand. Hopefully, we do a few more of these in the future. But reasoning LLMs are very new, and I think there's a lot of questions about how to leverage these things, especially when you have all these type of different language models out there and different providers. And a lot of the new announcements today, like model announcements, are going to be, will have this reasoning capabilities. So how do you use it? Hopefully, we get some answers today. But I want to show you, I want to call out this link here. So this one here is something I am maintaining. So I'll try to keep it updated as much as possible. But here are sort of the options that I've found with models that I work with and I have a bit of experience with. So this is like Cloud 3.7, Cloud 4, since we did the last webinar, Cloud 4 was announced. So it's Cloud 4 Opus and Cloud 4 Sonnet. This is going to be one of the stronger models that exists out there today. It's one of the latest models, latest reasoning models that was released, and it has a support for hybrid reasoning toggle, so you can switch it off and switch it on however you want, whenever you need it. It also supports interleave thinking with tools. We did have a conversation about this in the first session where it could be useful. Hopefully, we have a bit more discussion about that as well. I think that's an interesting capability. Anyways, all the links are here for how to use Cloud 4. And now the pricing, the context window, I think the context window is a bit of a challenge when you compare it with something like Gemini 2.5 Pro, which has a longer context. You will see in the example that I'm going to show you today how that matters a lot when you have like longer context, right? For a lot of applications, you will use, especially agentic systems, you will use longer context window. So a bit more on that. Just wanted to share this because I'm working hard on this one and making sure it's maintained properly. All right, let's get into the discussion here. Again, feel free to ask your questions in the comments. We have someone helping us out today. Towards the end, I'm going to answer a few of those questions. So I think everyone should be on mute now as I get to present this, but I'm going to be looking at the chat if there's any question that's relevant to what I'm talking about. And towards the end, we're going to take in all the questions and then discuss the more important ones. As is with all these live webinars, we usually don't get the chance to, answer all the questions, but hopefully we answer a few of the interesting ones. Anyway, so let's get started with this. Again, all of you should up to now be a bit familiar with what a reasoning language model is. There's a lot of research going on about reasoning models and reasoning language models, and a lot of the new developments have been around how to make, how to build and train reasoning models that are very capable and can do more, right? So it's not just producing or generating text, but now you can do things like interleaving reasoning with generation, with tool calling, all in one shot. And we have seen a glimpse of what that looks like with the O3 model, and now we get it with the Cloud 4 model as well. You may be wondering, what is all of this going to enable? I did a recent streaming on this actually last week when Cloud 4 was released, and I think their host has some interesting, ideas. I want to share this one as well with you. So I love sharing these resources because I think they do inspire a bit of deeper thinking. So I'm going to share this one with you. I'm not going to go through all of it today, but there's some interesting things that these reasoning models they do have. The one where it's interleaving tool calling and generation is an interesting one. You'll learn more about that here. But there's this capability stuff that I want you to look at. And then the other one would be how it improves Cloud Code. There's a lot of content on that down here and some of the performance rate and how it compares with all the other reasoning models. So always you want to check what's the latest model, right? How it compares with the previous ones. Now, there are not a lot of like new features and things like that, but I think this model is probably one of the most capable models today. And like it's really good at code execution, right? It was integrated with Cloud Code. Like the MCP connector is just a very standard feature. But there's one thing I want to call out in this one. Let me go back to the actual thing here. Apparently, what they found out is that when they were developing this system, I think it's the one with the game. So down here, I think what they realized is that when they were training this system, right, when they were testing it, before, obviously making it live for the public. What they found out is that it's really good with like keeping memory of things. Like you can keep memory, you can take notes, memorize key information. This is what they're saying here. And those notes can be used, right, to make the right decisions in complex environments. In this case, it's like playing Pokemon. But I think that's the promise of what a reasoning model can do that a standard chat LLM would not be able to do, right? The standard GPT-4o, GPT 4.1. Those models will not be able to have that ability because they were not really trained and they don't have that, capability. But these reasoning LLMs do have that. Again, because it has the tool calling capabilities, right? It understands that there is or like complex environments in which like applications will operate. And in one of those components is going to be memory, right? So lots of conversation around memory. So I think this was an interesting one, or probably the most interesting one for me. But there's a lot of little interesting things that they shared here, like results, some improvements that they I think with some integrations they had, like with some of these companies, and a lot of them are code related because obviously code, you work with a lot of files, multiple files. So if that's a use case that you work on, like you work on with lots of files and so on, I think Cloud 4 is worth looking at. So just a quick like recap of Cloud 4. I did a live streaming on that. You can find it on my YouTube, where I go deeper into all of these things. But I won't cover more about that here. I'm going to focus more on our like use cases. All right. So as with any of these newer models, I always ask the question, and we love experimenting, like where can we use the systems and actually get value from it? It's great to experiment, but where are they providing unique value? I think that's the main question that we should be able to answer, that we should want to answer here for all of us. Whether you have a developer background, where you don't have a developer background and you're using like some low-code tool, right? You still have access to these models and you want to be able to tap into them. But the question becomes, how do I actually use them, right? What's the design patterns that I should be focused on? Now, I would say that where we have found luck, as I said in the like success in the first session, I was saying that it will be like things like planning, right? And then it will be things like building an agentic RAG system. I'm going to share a demo with you, and I share the template with you. So I'm using n8n for this. A lot of you are probably very familiar with n8n. And we're doing a lot of stuff around n8n, and I developed a nice agentic RAG example here. So I'm going to get into that in a bit. And then this idea of LLM as a judge is the other one. And I think this one is going to be super interesting. Now, I really want to add one more here, but I haven't done the experiments yet, or haven't really gotten the results yet to really show that capability. And that would be this idea of like the memory stuff. I think, like managing context, managing information for the agent or the LLM, I think is so crucial to get good performance from the system. And the more the system or the more the language model can utilize that context and memory, the more effective that system is going to be. So that's something that I'll work on. For now, I'll leave that as a question mark, but we might have another part where we talk more about this and how it really applies for when you're developing with LLMs, and especially these reasoning LLMs. So more on that soon. Okay, so let me go back a little bit here. So as I mentioned, so the main things you use reasoning LLMs for, planning is one of them, where you have some kind of planning component. So you may have like an agentic system, right? Like this, where think of this as like some deep research tool where there's going to be different searches that are going to be performed. And we have sort of an orchestrator here. This orchestrator system needs to understand, create a plan of how it's going to do the searches. So if you have used something like deep research from OpenAI, they're using an O3 variant of the O3 model, and it has the ability to like do the interleave, like tool calling, generation, and it can also do a response as well. But how can it do all of that, right? That is what it was trained to do. So it can think deeply about information, and especially diverse types of information. Okay, so that's one. So where you're planning searches, you're planning whatever it is that you're planning for your agentic system. It doesn't necessarily have to be search. I think search is an interesting one because obviously you need to orchestrate how that search is going to happen. But it could be with it could be with different things as well. So it could be as simple as, let's say I need to generate like a video, or generate or do something to an image, or operate on images. The more you have, the more you use a reasoning model to like lay out the plan of tasks that it needs to perform, I think the more performant that system is going to be. So this one generalizes well to other areas. The other one I'm interested to talk about is this one, and I'll spend a little bit more time on this. I believe the last time we touched on the webinar, we did a deep dive on this one here. And so, maybe we'll share some more examples on that later on, but I really want to focus on this one because we have a nice demo. And I think there's going to be a lot of interesting questions for that one. So let's just emphasize a little bit on this one. I think also for all of these, maybe this one is going to be more accessible and more applicable to people that are like programmers, people are developing with these LLMs and are doing evaluation and all these things, right? So more technical folks, I think this will be more interesting. This one as well, I think for people that are building web applications on top of AI agents, I think is useful. But this one, I think, is going to be broadly useful for as many people as possible, for a lot of you. The reason I say that is because obviously this is going to be one of the biggest enterprise applications, and this is what I've seen. So I think this would be an interesting one to sort of cover. Now, the question is, here, it was easy, or not easy, but it was clear that planning is really important. How about in an agentic, in a RAG system? Where might I use agents? And where do I use reasoning LLMs for this? It's not very obvious from this diagram. This is a very simple diagram. So that's what I want to get into today. And the best way to show you this, obviously, is to show you a demo, okay? So I'm going to show you a demo first. We'll see how much time it takes. Ask your questions, ask as many questions as possible. It's a very simple demo, I must say, but I think a lot of you will appreciate how powerful it is when you actually plug in a reasoning LLM. If we get some time towards the end, I'm going to answer some questions, and then also I want to maybe cover a few of these prompting tips, because I think all of these could be interesting conversations on their own. But yeah, the content is there, if you have any questions, just always reach out to us and I can clarify a bit more on that. And hopefully we do that in upcoming webinars. But let's focus a little bit on this example here. So what is first of all, what is an agentic RAG system? What do I mean by that? So most of you are familiar with what a RAG system is, which is like a retrieval augmented generation system, which means you're using a language model and you're using a retrieval component. Retrieval could be as simple as a web search, or searching from a file based on keyword search, or searching from a vector database. That's how I define a RAG system, okay? So it's not just the vector store. There's a lot of confusion about that. I come from the information retrieval space, and that's how I define it. So just want to be very clear about that. And from there, now, how do I use a reasoning LLM? So again, it's not so clear here, but I have this thing called a retrieval agent. So let's take a look how this might look in an implementation, right? How it looks as fully implemented. So let me just go here. All right. Okay, so all of you, hopefully you stay towards the end of this one, because I think it'll be useful, and you have the templates here if you want to load it, but you will see the instruction. I'll give you all the instructions here. I think this is useful for anyone, literally anyone that's building with language models. And so that's why I was excited to actually talk about this, and I spent some time putting together a little demo for everyone. So let's go into the demo here. So I'm using n8n. So we have a lot of stuff going on around n8n. We have a live course that we're also we're going deep into the n8n, right? And it's an automation tool, but it also gives you the ability to create agentic systems and build them very easily, and create very effective systems and powerful ones at the same time. So I'm very excited to actually use this tool. Obviously, if you know me personally, I do tend to lean towards coding things from scratch. I've always done that using something like Python or some JavaScript web framework or something like that. But I think for this use case, it makes sense. I think it's more broadly accessible as well if we do it in a visual way. And this tool, you'll see how amazing it is. So let's go into the example. So I have 3 different workflows that I've created here. And again, you will find the workflows if you want to replicate this on your own. You will find them here in the templates folder here. Let me go back here, and I'll be adding more here as we cover them in future webinars. So the first thing I want to show you is I want to show you the high level this agentic RAG system. How would you build this in in the most basic agentic RAG system that we could build. So let's open that. All right, here we go. So we have this very simple agentic RAG system that I've built. And what I'm using here is I'm using this, what I refer to as a supervisor agent. So this agent here is going to literally orchestrate the work or orchestrate the task that the system will need to perform to answer a specific query. So I'm going to run this for you, and you will see what the application is here. And I'm going to show you all the components and explain to you how this all works and where the reasoning LLMs actually come into play. So what I've done here is I've actually combined two sources of information. You make your RAG system what you want it to be. You're combining an agent or an LLM, and you're combining it with different sources. Nothing stops you from using any kind of source that you want or any kind of retrieval component. It could be very basic, it could be very advanced. It's up to you what you want to do there. And so I've integrated a document search, what I refer to as a document search, and this is my internal knowledge base. For this example, what I've used is I've used this guide right here. And the reason we use this guide is because in our company, we do a lot of educational stuff, we do a lot of consulting work, and we do a lot of training, like trainings for developers. So we are always looking, to put together these guides that help developers, right? They go in and they find the examples, and it's pretty useful for them. But one thing that I love to do also as a researcher is I love to look at this content and keep it as updated as possible. And a lot of the new ideas are going to be found in areas where you don't visit every day. So it's going to be found in papers, it's going to be found in like some report that was published or some insight that was published by some company. And sometimes you will even find them in YouTube videos. So there's all of these sources that exist out there. And it's really hard to find these sources. So my idea for this agentic RAG system is that I want to use this resource here and I want to extend on it. I want to provide it more insights. I want to build an agentic assistant, or AI assistant, that can help me continue to iterate on this guide and make it as useful as possible for developers, like sharing insights, right? Sharing examples, sharing these new emerging patterns, sharing all the use cases, sharing all the prompting tips. And as I mentioned, some of these things actually come from places you don't actually visit every day, which is going to be like, like archive papers, is going to be like reports, things you don't see every day. So this is the ultimate goal of this system. So I've built a first iteration of this. And I think the results are quite interesting. How is all of this possible, though? What do we actually need to build something like this? When you are working with like complex data, right? Complex knowledge that the system might not, have complete understanding of, which is the case with these models. What do you use? Where do you even start, right? What language model should I use? So in this case, that's the perfect use case for a reasoning language model. So what I've done here is I'm going to show you here. So that's basically, I showed you the document that it's searching over, which is going to be that reasoning LLM guide. So I can ask it a question, something like, and it could be anything, right? You could plug in any data you want to it. It's up to you what you want to plug into it. Actually, this template, I've built it in such a way where you can plug as much documents as possible. You may have internal documents that you want to work with. You can plug whatever you want to it. So let me just give you this, show you the search, because this one takes a bit of time to do. So let me just fire this away, and then I will explain each part to you. Okay. So what are the reasoning LLMs use cases? We do have a few use cases here that we have summarized, right? Let me share with you that here. So yeah, a few use cases, the ones that I've highlighted there, and then these other ones that I'm highlighting here. What I would love to do, though, is like I'd love to build an agent that can assist me in extending further or doing more research around some of these ideas. Some of these ideas we have explored ourselves. Some of these ideas, we need to explore a bit more. But these are ideas that I've run into, either reading in some report somewhere, and I also want to extend it to see if there's some newer ideas there that I may have missed. An agent, that's an ideal system for something like this, because this takes hours of work, right? This is doing research, right? This is useful for us because we want to utilize the system to help people that we train. We also use it in our consulting engagements as well with companies that we work with. So this is a perfect use case for us. But it doesn't always have to be something like this. It could be any kind of document that you give it. In fact, I actually use this guide because I think this is very new knowledge. This is very novel knowledge that you would, again, typically find in like places that you don't normally visit on the web. So that's why I think it was an interesting use case to use something like this. All right, anyway, so I'm gonna go here and then I'm gonna fire this away. And then it starts, right, the process. With n8n, it's nice because you have this this trigger node here, which is connected to this chat window right here. And you can convert your agentic system into like a chat application very easily here. You don't need to build something on top of this. So basically, let's want to try to answer questions. You see how it's interacting with the tools, it's interacting with the language model, it's interacting with the other tool, it's interacting again with the language model. You can see the steps here, step by step, what's happening. You know, it's the document search is the web search tool, and then it goes back to the reasoning language model, and then finally the reasoning language model gave us a response. So let's look at the response and what this generated. So you can see here, without going too much into details, I asked it, what are the reasoning LLM use cases? It does have access to reasoning LLM use cases, like a list that I gave it. So I'm expecting that this system will summarize, you know, the use cases. But you can imagine if this was like hundreds of pages. This is like how long this is? 9 pages. But if it was hundreds of pages, you can start to see how useful this will be. And in order for you to actually, the bigger this document is, the more diverse information it has. Like it has a lot of different things, right? It has use cases. It has access to this. It has like some design patterns. It has prompting tips. It has different kinds of information. It even has some links here at the bottom and so on. So yeah, if this was 100 pages, it starts to make even more sense why you would want to use a more powerful language model that can understand all of that diverse information. That is a simple use case where you want to use a reasoning language model. You should be experimenting with a reasoning language model for this, and you want to use the latest model for something like this. Because what you're aiming to do in the first iterations of this application is to focus on accuracy. Accuracy should be the first concern. We're going to worry about costs and so on later on, because these models can get expensive, but that's a question you would answer later in future iterations. Okay, so let's look at the result. Let's look at and qualify how good this result is. So it says reason language models to give me a definition. I'm not interested in that. You can see that it actually looked at the guide, and then it says it's summarizing what is in the guide. But also something interesting, notice it's highlighting something here. So what is this? So it says reasoning LLMs excel at planning and executing complex tasks for agentic systems. They can break down large goals into smaller, manageable steps, orchestrate information retrieval, and determine actions. This is useful for creating sophisticated agents like deep research agents, exactly what I said, that can autonomously gather and synthesize information. And then it provided me a link here. Where is this link coming from? So let's check that. Is this an actual link? Okay, so the search here say the website here says how reasoning AI agents transform high-stakes decision making. I already like this. I think this is already, and it looks, it's very relevant, it's very new. So that I like those two things. But anyways, so this looks like something really interesting already that I can like sort of leverage, right? Can look into this. Look, it has some, you know, reasoning AI agents in action, healthcare, customer service, finance, logistics. So you can see just on that first click, just on that first link that the agent found for me, it's already starting to become very useful. It has like, how can I design a reasoning agent? It has mention of DeepSeek R1. I saw someone mention that here in the chat. And then maybe potentially some tools that I can use and so forth. So this looks like a very nice guide. You know, as a developer, I think I'll find a lot of use for this. So this is actually really valuable. And it's not going to be every link that's going to be valuable, right? So that's one. I like this one. So there was no mention of Agentic RAG, and that's okay. There might be a little bit more work that I need to do here. With my agentic system. So there's LLM as a judge as well. I think there are many examples of this, but I couldn't find anything. There's visual reasoning as well. I think there are some good articles out there. But you can see that here also it provided some kind of resource as well to kind of back this insight. So it says explore reasoning LLMs with their real world applications. So let's click on that, see if that's a valid source. It is a valid source. This one was published in 2024. As you can see, reasoning LLMs were already very common there. This one is talking about Cloud GPT-5 Sonnet mainly. Anyway, so it has like maybe some interesting example here, and application. Maybe it even has a prompt here as well. So this is neat. This is actually useful too. So I will spend some time looking at those later. And then we have like multi-step planning. I don't think I mentioned it too much in the guide, but let's see. Let's look at this if it's a valid link. Okay, so it's using the same resource. So apparently that was mentioned here. All right. And then it says industry-specific applications, healthcare. We have one for healthcare. This is from the same NVIDIA post. same sources there. So again, it's looking at the same sources. Let's see if there's anything new here. Okay, so those are new. Those are okay. So those are the same. And then we have. So it's important to note that while reasoning LLMs offer significant advantages, they are still an evolving technology with limitations such as potential inconsistencies, cost latency, and challenges in instruction following. And then it says LLM reasoning. I'm afraid to click on this link because this is my prompting guide. But anyways, I'm surprised that it actually found my prompting guide. And that's great because I think this prompting guide has been useful for a lot of people. Oh, yeah. So I even forgot that I actually wrote this. So this is a resource that I should be linking in our guide, by the way. And I completely forgot that. Let me just add this link here. So you can see that this is so useful, right? Like I'm actually in live editing my stuff here. I completely forgot about this. But anyways, it's a nice introduction to LLM reasoning. And I think I wrote this last year. And it might be outdated a bit, but I think it's still a good resource. It has like a lot of paper stuff that I was talking about, and then a few additional links. Anyways, so that's what it found. That's great. Let me go back here. All right. Okay, so let me give a little bit more context now. So why was it able to do this? What exactly is it that I'm trying to achieve here? So let me go through the different parts and why we had to use a reasoning language model for something like this. So I'm going to go here first, and I'm going to give you, explain to you the prompt itself, right? When you're prompting language models, when you're prompting these these reasoning LLMs, you want to be very specific and you want to be very clear about what is it that you want the system to achieve. Don't worry too much about telling it step by step and all those tricks. Those won't work with reasoning LLMs. What you want to do is you want to be very clear. What is it that you want to achieve? So what I've told it is, like you're a helpful assistant who will help to answer user queries by searching the internal docs, and performing extended related research using the web. You will first search the internal docs for insights. If you can't find any insights regarding that query, respond with, I couldn't find any internal information regarding the user question. If you find related insights, then use the web search tool to look for related insights. That's why I was able to find those related like links, right? And make sure to cite the sources and use this format here. When there is an insight, use from the web. That's it, nothing more. This system is great. This language model understands the instruction. It's very clear. That's what I want to achieve. I can continue to add more to this, but that's the demo right here. Okay. So now, when this fires off now, what it's going to do is going to use first the language model. And let's look at the language model, what language model it is, just to show you here. So I'm using Gemini 2.5 Pro Preview. So this is one of the models that have like the reasoning capabilities, can think. If you want to test this model separately, you can always go to Google AI Studio, and you can look at the reasoning tokens in the AI Studio. So here you can just search. It has this one. I think this one is the latest. You can just ask it something. So you can tell it, what are the latest releases from OpenAI? You can tell it something like this. And then you can run this. And then it's going to think. So that's, this is the reasoning part of the model. And then it's going to produce some output. Okay, so you can look at the reasoning tokens. So the reasoning tokens are going to be all of that. And then it's outlining its response, which is this part here. But the great thing is that you can see in the studio, what's generating as part of the thinking process, which is useful when you're debugging the system, when you're trying to improve it. However, as I've been saying, I think I said it in the first webinar, that this is not available with all the models. Some models only provided in their playgrounds and studios, and they're not available in the APIs. But the good news is that most of the companies and LLM providers are working to at least give you the summary of it, which means this summary here. So not the raw tokens. I think that's where open source models actually play a significant role, because open source models are going to give you those thinking tokens and you do whatever you want with it. As a developer, that's going to be a useful way to improve that system. Gaining insights into how this model reasons about certain tasks is going to be a useful part of the development process. And this is why they're even giving you a summary of this. And I'm not sure how useful it's going to be, but at least you have a summary of what the system is thinking. Let me go back here. So yeah, this is the model that I'm using. So that's the reasoning model that I'm using right here. And again, the reasoning model sort of guides this agentic system. Like it knows when to do a document search, right? It's following that procedure that I gave it, that instruction. And then it also is going to use the web search. And because these two things are going to give the system two different types of information, or different types of sources and information, is going to try to make sense out of that information and then generate a response. This is what it was able to do this. This might look like a very simple answer, but I can tell you that these systems, these standard language models, really struggle with something like this. Now we kind of get this capability, and that's nice. I think, without hyping it too much, I think this is what I saw, got so excited about deep research when OpenAI released that product, that deep research product, because that's the first time I really saw that, like, an LLM or agentic application can look at diverse types of information and then reason about that information and produce consistent and high quality outputs. We cannot take that for granted. That stuff is super powerful because, again, there's so much knowledge and so much information that we have in our workplace and we have out there in the web, and we don't have really intelligent systems to make sense out of that information. So this is very basic, but I think the more complexity you add on it, the more you will appreciate how powerful this reasoning language model actually is. And this example shows you that. So let's do a quick experiment here. Just, I'm making a lot of claims here, but I actually like to test this live. So what I'll do is I'll switch off from 2.5 Pro Preview, and I'll try some other model that's, doesn't have reasoning capabilities. And let's see how the outputs compare. So let me try to use, I think I want to use, OpenAI models are generally the better models. So I want to use GPT-4o. I think that could be a good comparison because GPT-4o is one of the best chat language models that exists out there. And let's see how a chat language model would compare with a reasoning language model. Let's see that. Not a fair comparison. That's not the point. The point is I want to look at the quality, right? And that will show the quality improvements, and it will show, and it will make you appreciate more the outputs that we're getting. So let's save this, and then let's run the question again. I think I should have started it from scratch. But anyways, hopefully it doesn't use this context. So that could be tricky. But I think it doesn't have memory, so it should be fine. So let's see what it does. I should have run this entirely in a new session, though, because it might want to use this. Anyway, so it's moving fast. Look at it. It's so fast, right? Because it's obviously a standard chat language model, and these are usually much faster than the reasoning. It's super fast. That's great. Okay. So let's look at the results here. So it referred to this link here, and then it refers to this link here. So it looks like it did pick up two different links, but let's look at what it responded. Okay, agentic system. So this is the stuff that I was. So basically, it's like maybe word by word what I was talking about in the post. And then it has some external insights. Okay, the external insights. Then it has some links here: customer service, inference, computer optimization. Then planning frameworks, then these highlights. Okay, so it does have a few interesting things here. Not sure. Yeah, this is super weird, right? So yeah, so it tries to add a citation to this one. But if you look at my command here, my instruction, right here. So here I told it make sure to cite sources, but I wasn't too specific about it. The other model actually was intelligent to know that these are two different sources. And it was only citing the sources that came from the web search, right? Not the search. In fact, I was very clear about that here. So the ones that are coming from internal knowledge base, we didn't have to cite that. Unless we wanted to cite that, then that would be more explicit. So I think that one is not so great. But besides that, it's very plain. It's not as as detailed as this one. I think like this is a research task. It's a search task. And so I think I want more details. I'm expecting more details. I'm expecting more insights. I'm expecting more explanations, right? And I'm expecting that the citations are actually correct. And that's the difference, I think, between the reasoning LLMs and the standard GPT-4o models. I would say that the GPT-4o model, though, has been improved a lot. It does have like strong capabilities. And I think this is one of my favorite models that is not a reasoning model, actually, GPT-4o. If you try it with something like GPT-4o Mini, I think you will get worse and worse results. But just wanted to call that out. Oh, you even get a link here. I wonder if this is useful. Yeah, so when reasoning beats, okay, so this is one reference. I like that I actually picked up that. However, I must say that these links that you see here, right, where are they coming from? So let's look at that a bit. Let's try to explore this a bit and why I wanted to use a reasoning LLM. So one thing that I want you to keep in mind in this experiment, in this application, right, is that what I want to do is that this is the first iteration of the search application, and I'll be adding more documents. I'll be adding more complex web search. So in this case, it did one web search, but I'll be pulling in hundreds of resources, hundreds of references. The more that expands, the more context you're giving to the system, the more capable this model will have to be. That's why I was experimenting with the reasoning language model from the get-go, because I understand that that's going to be a requirement of this application as I think about scaling it further. I think this is the way to think about these systems, right? Experiment with them, compare them. Let's start with a very basic iteration, and the more complexity you add to it, keep in mind that you have these powerful systems that you want to use, and always be comparing, logging things, and differentiating these results that you're getting. So let's get into like the actual, the search results, how they look. Not so important to the demonstration here, but I think it's still important to just show you briefly if you want to replicate this yourself. So let me go here into the webinar stuff. So there are two workflows. The first workflow is quite simple, actually. It's basically using XSize, and XN is the API where you can do web searches. And basically it's going to just do like an API request. It's just going to use the query, right? The query that it gave me here. And then it's just going to say, okay, search this. The API literally just returns the results from the search itself. Nothing too intelligent here. And I was saying, right, like if I add more requirements to this, if I add more complexity to this, what is the thing that I want to add here? Well, I think that's an interesting one, because this one is only using one HTTP request, literally just a tool calling an API, that's it. And then just sending that back to the agent, the supervisor agent. However, for this, what I want to do is I want to make this system more intelligent. And what I will end up doing is I want to have one component that plans the search. That's why the search is not so great, the search results that we got, that we're getting from these APIs. And it has nothing to do with the API. The API is one problem, yes, so we need to optimize that. But we also need relevant searches. We need to send the system, what is the search of the thing that we want? And in this case, it said, so this one, it has this example here, tell me about, but this actually is not the actual search that it's going to perform on the API request. But if we can have a little bit more control over what are the search queries that are going to the web search tool, I think that could be super powerful and actually improve the system. Essentially, what I would need to do is add an agentic system, another agent here, and connect this XI API request. What am I talking about here? Well, it's going to be the other design pattern that I just mentioned, which is going to be exactly this part here, which is planning, right? So this planning thing here. Essentially, what I want to build here is a planning component. And the planning component or the orchestrator that's going to orchestrate the searches are going to be done by a reasoning language model. Another reasoning language model that I can use here. It has to be a very smart system that can be able to do that. On top of that, as I think to add more and more complexity to this agentic system, what I would love to do as well is I would love to refine that search, right? I would love to refine that plan. So the initial plan is going to take care of doing a couple of searches, pulling that information. Once it's pulling that information, the language model, the agent will have that context, and it will qualify whether that context is important. And then it will try to sort of fix or try to improve. It's going to maybe search other places. It's going to maybe improve the search queries. So that refinement process is something where you can use another reasoning language model for that, because what the model will expect or what you will give it as an input is going to be the history. It's going to be the history of searches, and it's going to be the history, the history of searches together with the results, potentially other information as well. But to do that refinement, it's going to be a massive document. And it's going to be a document where the system sort of needs to understand the context, sort of needs to understand or memorize all of these different operations that it has done in order for it to kind of improve itself. Right? This is what is referred to as a self-improving AI system. that's ideal for a reasoning language model because it has so much information. I think this is what Cloud 4 was actually trying to highlight, that when you do things on multiple files, if you have a code base, there's so much complexity into a code base. There's so much stuff going on there, right? Every script is going to do different things. It needs to understand the structure. If there's an edit here, another edit needs to happen over there, and so on and so forth. So that is really what these reasoning models are pushing, right? That's why a lot of companies are spending a lot of resources on this. So that's a little bit on how you can sort of extend this and think about how to integrate reasoning LLMs more and more into this type of agentic systems. The last one I want to cover here is this document store. It's very plain, very simple. I'm using a doc search agent here. By the way, again, you see I'm using this reasoning LLM. In fact, what I've done here is I've actually used this, because it could be very expensive. Just keep note of that. Like if you're using reasoning LLMs everywhere, like that adds up and it could be quite expensive. Like so just be mindful of that, okay? Like it can be super expensive. So what I've done is actually switch it off to 4.1. 4.1 is actually great. Also very expensive model, I would say, compared to the other ones. But this model is great for very simple things. And basically, this one is basically just going to, so what does it do? So I refer to this as some sort of retriever agent. No vector store here. You see there, I don't have like a pinecone, don't have any vector store. And this is another way to actually retrieve information where you're using, it should have been a reasoning LLM, but I wanted to actually take that away from here. But basically, the reasoning LLM is going to retrieve information. Think of it like, a lawyer going through a long document, or, a financial analyst going through a long document and just kind of highlighting this, highlighting key information that we need to provide as context to some task that is being performed by a team or manager, or whatever that may be. So that's what this particular system is doing. The document itself is, again, you can try it here because this is public. You can literally go and try this ID of this document, and that's what I've used. But you can plug this out, plug in whatever document you want, okay? Just plug in whatever you want here. And that's what it's using. So let's look at the prompt really quickly here. So retrieve and summarize the top 10 relevant sections from the document, output a list 1 to 10. So this is a relatively new idea, right? Where we can use a reasoning language model to like highlight key information, send that back. As we saw, right, we did get relevant information. We did get information, and this is responsible for that. This agent here is responsible for this, for that particular, results. So what I told it to do is you're a helpful assistant that will look for an answer for the user query. So it has access to that query, right? So the query is there. You have access to tools which are Google Docs, where you can retrieve information, retrieve and summarize the top most relevant sections from the document. This is why I get excited to talk about language models, because this is not something you could have done very easily, just a couple of months ago. And now we have these reasoning LLMs, we have these more advanced systems that can look at large amounts of information, extract the information that's relevant, and that basically replaces what could be like a vector store, right? Like a vector store is doing, is doing the semantic retrieval. You need to like set up a vector store, you need to store this index, you need to retrieve information. All that process is being replaced by, by an agent, by a language model. I am not claiming, or I'm not saying that this is better than a vector store, but this is an interesting way to use the reasoning LLMs as well to retrieve information. Some people refer to this as reasoning-based retrieval. I think that's going to be a new, like an emerging term people are going to talk about. If you haven't heard it yet, this is the first time you're hearing it. Well, great for us that we're talking about like new ideas. But anyways, so plug many tools, plug many different guides here, plug whatever you want to plug here, want to give it as some kind of knowledge base, and continue to experiment with it. What you will realize is that the more you add, the more diverse are the documents that you're adding, the more it's going to require from the language model to do. And that's where the reasoning language model comes into play. Okay, I want to make that very clear. So complex understanding, right? Understanding diverse information, planning whatever it is that he needs to plan, like reasoning about information as well. So all of these things are what reasoning models are really good at. Very basic, but you can extend it as much as you want. This is ready to be scaled because we're using the reasoning LLMs. All right, so that's enough for the demo. I want to go back here and then answer some questions. Let me see if we have some questions here where I can answer. Hopefully that was interesting. And it's something that you want to play around with. That's kind of the idea for today. But definitely we have a lot of cool examples that we want to share later on in the future. But yeah, let me see if I can answer a few questions here. Okay, so we have a very long question here. Not sure. Okay. Wanted to open a discussion regarding model architecture strategies. Are these architectures where a high-level reasoning model is used for complex tasks, while smaller models handle simpler tasks like summarization? This approach could potentially help optimize token usage. Separately, I've been experimenting with the setup where a smaller model acts as a primary agent, only handing off higher-level reasoning tasks, yes, to a larger model. When necessary, my testing indicates the smaller model frequently doesn't identify the need for a handoff correctly, doing so about 80% of the time. Could we discuss effective ways to implement this conditional handoff mechanism? I'm looking for guidance on how to make this reliable. Yeah, so I think this is such an interesting, conversation and discussion. So what I can share here is that I think in the future, and I think I shared a paper today. I had my Twitter open because I share so much of this stuff, by the way. So here I shared this exactly what this question is. I think it's related. So basically, this model was trained. This reasoning LLM was trained to do slow thinking, which is basically the chain of thought stuff, the reasoning stuff or thinking, and then to sort of also generate faster responses. And it does that, it does that itself at test time. You don't need to like hand off. You don't need to. And it does the handing off itself. Like it knows the optimal point where it needs to go fast and when it needs to go slow, right? It needs to go slow because it maybe needs to think more deeply about something. So this was an exciting paper, I think, that talks about this, but there's a lot of really interesting references that were mentioned in the paper. So Chetan, if you want to dive deeper, I think this could be an interesting resource for you. This is something I've been talking about. So far, I think what we have is we have these reasoning LLMs that you can toggle off and toggle on, but that's a decision you need to make, right? I think that's still okay. However, from a practical point of view, it'd be great if the system can decide itself when to use it and when not to use it, right? When it can be switched off and when it can be switched on, when it needs to be switched on. And I think the way to think about this is like exactly how I shared. I think it's good to be in control, right? Not to hand off this to like an agent and let that agent or API service decide for you. I think it's better you have control over that, better to have understanding of what the small language model can do and what it cannot do in your domain. Yeah, sorry about that. That was my fault. I pressed the wrong stuff here. Yeah, let me share my screen where I was. We have about 10 minutes. I'll try to wrap up now. Why is it not allowing me to change? Okay, there we go. All right. Yeah, that was an interesting question. I did provide an answer. I'm not sure how much of it you got there. But I want to go into another question, and try to answer a few more. Okay, so I'm trying to set up a custom reasoning model, custom API endpoint, and custom SSL certificate on a Docker-based local n8n setup. Is there any way to set this up. Yeah, this is an n8n question. I won't be able to answer this in this call because this wasn't focused on n8n. However, if you can send me an email, I'll try to offer you support separately, okay? Let's see, search. Yeah, or reach out to me on Twitter. I'll try to get you some help there. All right, so this one is more related. When we do a web search, we might know based on our industry which websites could have relevant content. Example, in my case, healthcare, I normally look at NIH and so on. Can we route or give direction to reasoning model to look at these and related websites rather than let it think on itself? Is it possible? If it is possible, would it be possible by prompt? So there are a couple of ideas I can share with this one because this is something I've worked on. Let me see if I can share directly here. Why is it selected out? That's really weird. Yeah, this folder stuff on n8n needs work. I've seen a few bugs with this. Okay. Yeah, so you can use this idea of like use the reasoning LLM to do the plan for you, right? And make sure the queries are optimal for that domain. That's why I think one application where you use the reasoning LLM for that. So that's more the planning. But then on the search side of things, you can use an API that limits the domains or sources. So that's more configuration on the domain side of things. The great thing about doing it, it's something like n8n, is that you can make that stuff dynamic, meaning whatever the reasoning LLM decides the searches are going to be, you can sort of give it a couple of domains, and then we'll just try to figure out what is the domain that it needs to use and fill that up as part of the HTTP request, right? So typically, you want to maybe experiment first by keeping it static, like you define the sources to the API request. I think Exa does excellent at this, and it's actually one of the reasons why I use Exa. So this, why is it opening? This is so strange. All of a sudden, it's not working. Wow, so weird. Yeah, something happened. Oh, there we go. Yeah, so this Exa API request here. So Exa is an excellent API, and it actually allows you to define here as part of the parameter to define the sources that you want. So you would, this is one way you would do it. But as I was saying, right, you may want to like give the system or the higher level agent, supervisor agent, a couple of sources, and then let it decide for you and let it, fill out dynamically. So when the API request does goes through, let that be dynamically done, or select the sources more dynamically. And also another, like this is the idea, right, that I was talking about here. So when I do these searches, I'm actually searching different sources: academic search, news search, web search, but those could be specific domains. How it decides which domain to call and what's the query for those domains, well, that's going to be decided by the orchestrator. This is why I think this architecture here is a relevant one for what you were asking. So hopefully that's useful for you. Okay, I think it was, yeah, Shivi was asking that. All right, you can do it in the prompt, you can do it in the HTTP request, you can do it with the with the reasoning LLM. Be more specific with the instructions. Yeah, there are different ways so you can do it. All right, so this question would be nice to do as well. So the question is how to get better structured output from reasoning LLMs, use a specific prompt, or maybe process a regular LLM to clean up and structure the output of the reasoning model. I'll share a few things here because I think this is so important. Let me, just based on my own experimentation, my own work, I actually put that here. So there is a specific section. So I'll share, there are a couple of things to keep in mind here. I think the format is really important, right? Like, oh yeah, so the format. So a lot of people like work with JSON. I think JSON is one of the standards, right? And then, but these reasoning LLMs actually work great with XML content as well. So if the requirement that you have in your application is not JSON, you don't need to use JSON, then use XML. And the reason I'm saying this is because for some reason with the XML stuff, it doesn't affect like what's being generated in terms of the content itself, what the model is giving you. And I noticed that with JSON, it sort of constrains. It has some constraint in the generation itself. So I want to be careful about the JSON. And if you think about it, that makes a lot of sense. Because like not everything in that JSON object, the model has seen probably millions of examples of JSON objects, right? But typically JSON objects are very concise in nature. And then, XML would have more diverse more diverse patterns, right, in terms of content. So I think that's one of the reasons why. And I think XML is actually much richer for the system, because when you're doing XML, you are describing the tags, and you have like you close it here, so it naturally has that structure that the system understands. And also because these systems have been trained a lot on HTML data too, so HTML is kind of related to XML in a way. But anyway, so those are just some things that I wanted to mention here on the formatting side of things. Now you can use, I think somebody mentioned there, you can use something like Agentic, something like that. To achieve this is one way to go. You can use to make it more reliable, right? So from a reliability point of view, that could be useful. But on the prompt itself, so you want to use, my recommendation always for structured outputs is, regardless if it's an agentic system, regardless if it's a reasoning language model, whatever you are using, is to combine. So you want to be explicit about the schema that you want. So if it was XML that you were using to structure your information, tell it what is the schema of the output that you want, and also maybe couple that with some tool out there that can structure the outputs for you. Some of these APIs do support structured outputs. However, I would say that they're not too perfect, and I would typically for this I would prefer to do my own structured outputs. I think the OpenAI one is really good. That's the one I've experimented with a lot. But typically you want to like combine things, right? You want to use the structural output tool, and then you also want to reinforce that in the prompt itself. So both approaches together usually works better for most of our applications. Yeah. So one more thing I wanted to cover, which is something I was reading about, and I've seen it in a couple of papers. I actually want to highlight this because I think it was super interesting finding that I made recently. So basically, what Cloud4 found, based on their documentation that I read yesterday, so basically what they're saying is that you want to be a little bit careful when you're structuring things, because if you're structuring things, like if let's say you use like a prompt that has like a markdown structure, what the generation is going to be more markdown. And let's say you didn't really want markdown, maybe you wanted to generate like a raw code or something like that, or some kind of format like that, right? Specific format. This is going to influence, right? Your prompt structure is going to influence the outputs format. So just be a little bit careful with that with the reasoning language model, because again, with the reasoning language model, it's trying to do different things. It has different capabilities, but in that process, it sort of, in a way, becomes really dumb to do other basic things. Like it forgets to do other basic things. One of those things is so important, which is tool calling as well. Like DeepSeek R1, for instance, notoriously cannot do function calling really well. The updates that they implemented are actually much better at function calling. But just be careful with these things, especially with reasoning LLMs, like these requirements that you're putting. That's why I was saying be very clear, be very specific. Try to use maybe even provide an example on the type of output that you want, how it looks, the structure. So that usually leads to better performance. Yeah, definitely. Yeah, so Terry, thank you for the suggestion there. Yeah, function calling too. Function calling is there, right? Function calling gives you already gives you the objects in the right format. Great suggestions. Thank you all for sharing that. That's great. It's great to hear people are using different approaches. Yeah. Let me see if I have any other question I want to answer. Can answer one more. I'll take one more. Let me see. Oh, okay. Yeah, it's going to be an interesting one to highlight. Okay, so this was n8n. So I'm going a little bit back. There's so much text going in the chat. Okay. Yeah, I don't think I understood this question. Why not like DeepSeek do? We are not revealing the correction and retries when the reasoning is not convenient to do the intended goal. Yeah, so I mean, I think it's related to that question, right? Like there's a lot of like efficient ways or more optimal ways we could be doing this. However, like I think this is a difficult problem. It's not like I like to see the research papers that how they approach this, and a lot of the times it'll be like fine-tuning, generating synthetic data, because the data is so hard to collect, and that's how you're going to reinforce the system to actually follow what you want it to do, right? The fine-tuning process. But when you do fine-tuning, as I was saying, it does forget other capabilities. So it's a tricky thing to actually be fine-tuning, like a reasoning LLM to to do the things that you want to do, because it might actually forget to do other things really well. So that's one thing, right? And I think like with models like DeepSeek, like as I was saying, like the function calling is not so great. But the question here is, I think the way how I understood this is like, shouldn't the model be able to correct itself? Like, shouldn't the model be intelligent enough to understand? This is like a thinking model, it's a reasoning model, it's an intelligent model, right? Shouldn't it be able to like just decide, well, I don't need to reason, so I could just output, like, this is what the example I shared. This is a very good example, actually. So what are the latest releases from OpenAI, right? And then it produces this output here. By the way, if you look at this output, it's kind of outdated. It's from 2024. That's because the cutoff point for this thing is 2024. It's not using the web. There's no web connected to this yet. I haven't added any tools. When it could have just simply told me, like, I don't have access to this information, right? It looks like it's a really dumb system because it's giving me an answer that it shouldn't. But I want to say that this is a thing that we shouldn't underestimate, how difficult this is actually to build. And we don't have it yet because there's no easy way to do this. There's a lot of research happening on like the architecture, the reinforcement learning, right? How do we include better rewards? How to improve, how to train better reward models for the system? Because usually that's going to determine, how good the system is at the generation phase. How to do the reasoning more efficiently as well, because sometimes it's just going to generate stuff and it's just blabbering and it's not really doing much. Sometimes it overthinks, sometimes it's underthink. So there's a lot of little problems like that we as developers need to be very aware of. And there's not a lot of great solutions. I think for now, being able to like architect things yourself, as I was saying with the previous previous question, having the ability to decide which model to use and when to use it, right? I think that's as good as it gets today. We don't really have good solutions out there that automatically routes, queries for you. But hopefully in the future we have better solutions for that. I don't know if you guys remember, but OpenAI actually promised to sort of unify everything, right? That was the promise. I don't know why they didn't do that and why they didn't go with that, because they continue to release these separate series of models, right? The GPT-4 series and then the O series. I think it's because it's a hard problem to solve. As much as, I like OpenAI models and so on, I think that's still very far away. Like, to actually create intelligent systems like that can be unified and can do everything for you, decide for you, when to answer and when not to answer, reasoning, when to use reasoning, when not to use reasoning, when to use function calling, when to use parallel function calling, and so on and so forth. And the list goes on, right? A lot of like different challenges with these LLMs. So just some extra thoughts there. I think that was it's an interesting development, but we don't have really good solutions for this yet, from what I can tell. All right, great. Thank you so much, everyone. Hopefully you learned something. Please give us feedback. We love the feedback. You will get the recording. You will get the additional files. I'm going to keep working on this stuff. The questions you ask me, I take those questions and I try to come up with better content. I want to do deeper dives of this stuff. I love talking about this technology and I build a lot with it. But I think, it can only improve if I'm hearing from you, what's working, what's not working, and so on, right? So give us all the feedback. I'll take all those feedback and try to improve on the next iteration. Thank you so much, everyone. Have a great day.